Hello, welcome to homework questions 31 through 36 from Chapter 2. Question 31. The set of equations below is an example of a system of equations. Read the math note box for this lesson on how to solve system of equations, then answer the questions below. So given two linear equations, graph the system on graph paper, then write its solution in XY form as an ordered pair. So let's go ahead and take the first equation. Y is equal to negative x plus 1. We have a slope of negative 1 and a y-intercept of 0, 1. So I'll get a couple points here. We get lots of them. And just make sure you use a straight edge. Label the equation since we have two of them. And we're looking for the point of intersection. So let's go ahead and take a look at the second one. With a slope of 2 and a y-intercept of 0, 7. So up 2 over 1, we can also go down 2 to the left 1. And so you can see right there is where those two lines will intersect. So for part A, the intersection point is at negative 2, 3. And that is the solution. It satisfies both equations. On part B, it says, now solve the system using an algebraic method of your choice. Did your solution match your result? If not, check your work carefully and look for any mistakes. So one way we can do substitution or elimination, this would be, or equal value method. And this would be a good one for equal value method. Since both of these are equal to y, we can just set them equal to each other. Negative x plus 1 is equal to 2x plus 7. Subtract 2x. Subtract the 1. Divide by negative 3, and that's negative 2. And then we can take that and plug it back into one of our two equations and solve for y. And we get a y value of 3. So that would give us a solution of negative 2, 3. And that is the same thing that we had from above. So it looks like we were able to check our solution. Question 32. On graph paper, graph the rectangle with vertices given. And then what is the area of this rectangle for part A? So let's go ahead and plot the points 2, 1, 2, 5, 7, 1, and 7, 5. And to find the area, we need to find the length and the width of the rectangle. We can see that that is a 4 by a 5, so the area will be 20 units squared. And then on B, Shirley has given the following points and asked to find the area, but her graph paper is not big enough. Find the area of Shirley's rectangle and explain to her how she can find the area without graphing the points. So what you'll notice is these x values are going to be the same, similar to what you see up here. And then it's the y values that is going to be the difference. So between the 5 and the 1, that's a difference of 4. So that makes one of the sides. So with the 75, the 175, and the 150, that's a difference of 25. So that'll be one side length. And then with the 456, the same thing up here with the 7s. You're still going to see that difference of 4. So we should still see a difference of 25, which we do here. So that's actually the same side. So then let's look at another one. We have 150. And let me erase so we can get some other stuff we can see here. So the 150s are the same. So we need to look at the difference between the 456 and the 352. And that's 124. So you'll notice the same thing on the other one, which means we have 25 by 124 rectangle. And so when you multiply those two numbers together, we get, I just realized I meant to write 104 and I wrote 124, so let's go 104. So 25 times 104 is 2,600 units squared. Question 33. Looking at the diagram below, John says that the measure of angle BCF is equal to the measure of EFH. So let's just take a look. BCF. So BCF and EFH. So EFH. Alright, do you agree with John? Why or why not? Well, it depends. It doesn't have that these two lines right here are parallel. If the lines were parallel, then the angles would be equal. Their measures would be equal, but since it doesn't say, we just don't know if they are. If the lines are parallel, yes they are, but if they're not, then they wouldn't be equal. On part B, Jim says, you can't be sure those angles are equal. An important piece of information is missing from the diagram. What is Jim talking about? Well, what we already said is that the lines, if they were parallel, should have had the appropriate marking. So once again, the diagram does not have the parallel lines marked. Question 34. Use your knowledge of angle relationships to solve for x in the diagrams below. Justify your solutions by naming the geometric relationship. So in the first one, part A, these two angles would be considered same side, corresponding, because this angle right here can be translated down to this one. So corresponding angles have equal measures, so we can set the two expressions equal to each other. So 5x plus 7 is equal to 9x minus 63. Subtract the 5x to this side, add the 63 to that side, and then we can divide by 4. And x is equal to 17.5. And once again, we know that because of corresponding angles. Alright, on B, we got a couple things we can do here. First one, we have this angle and this angle. Not the same, I shouldn't do that, but these two angles here is what we're looking at. Those are same side interior. So same side interior are supplementary. So we should be able to say that 12x minus 14 degrees is equal, or plus 20x plus 34 degrees is equal to 180 degrees. They're supplementary. So we can combine like terms. We got 32x plus 20 is equal to 180. Subtract 20 and then divide by 32. And we get x equals 5 degrees. We could have also done alternate interior angles, and those are congruent, so we could have said 12x minus 14 degrees is equal to 5x plus 21 degrees and solve that. Just to show you real quick, 7x is equal to 35 divided by 7, and we get 5 degrees. So a couple different ways we could look at that problem. Question 35. When Ms. Shreve randomly selects a student in her class, she has a 1/3 probability of selecting a boy. If her class has 36 students, how many boys are Ms. Shreve's class? So if there are 36 total students and 1/3 of them are boys, then what is 1/3 of 36? And that's 12. So that means 12 boys would be in the class. On part B, if there are 11 boys in her class, how many girls are in her class? So this is ignoring this part right here. This is going back to the 1/3 probability. So if there's 11 boys in her class, then 11, if that's 1/3, we know there's 33 total students. So then you can take 33 minus 11 to get 22 girls. What is the probability that she will select a girl? Once again, ignoring the things from above. If it's still a 1/3 probability of selecting a boy, then the probability of selecting a girl is 2/3. That's what's remaining from the 1/3. And then on D, Assuming that Miss Shreve's class has a total of 24 students, she selected one student, who was a boy, to attend a field trip, and then was told she needed to select one more student to attend. What is the probability that the second randomly selected student will also be a boy? So 24 students, 1/3 of 24 is 8 boys. So if one was selected, now you only have 7 boys out of a total of 23, because there was 24, but one was already selected. So the probability of selecting another boy would be 7 out of 23. Question 36. On graph paper, draw a line segment AB, given points A and B. And then we're going to reflect that across the line x equals 3 and connect the points. What shape is created by this reflection? So let's plot the point 6, 2. That's point A. B is at 3, 5. And then we're going to reflect it across the line x equals 3, which is right here, that vertical line. So B would stay right here. B and I guess B prime would be the same. A would reflect over here to A prime. And so we reflected it. If we connect points A and A prime, because I was already supposed to draw on the line segment AB, what shape is created by this reflection? So that distance, because here's the line of reflection, this distance should be the same, and so it looks like we will have an isosceles triangle. On part B, what polygon is created when AB is reflected across the line y equals negative x plus 6 and all endpoints are connected to form a polygon? And so I went ahead and redrew the figure, drew the line y equals negative x plus 6 as a dotted line. So now I can reflect across here. A prime would be there, B prime. And so if we connect everything, because of the reflection, A prime to B prime and A to B would be the same measure and the same across. So it looks like we're going to get a rectangle.